Okay, Wildcats. Today we're looking at Thursday, May 3rd, special right triangles on page 80. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, special right triangles on page 80. Now, before we start going over the sine, cosine, and tangent, and cosecant, and secant, and cotangent, go ahead and draw the right triangle with the highlighted sides. All right, now you have that drawn. Okay, now here's our angle theta. Now the side right next to the angle we call adjacent. Now the side across from that angle we call opposite, and the side across from the 9 degrees is the hypotenuse. Okay, so all of these are based on that right triangle. Okay, so sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over hypotenuse. Cosecant of theta is hypotenuse divided by opposite. Secant of theta is hypotenuse divided by adjacent. And cotangent of theta is equal to adjacent divided by opposite. So if you would update your trig functions. All right, now let's get into the 30, 60, 90 triangle and the 45, 45, 90 triangle. Okay, so wow, that's a very long and annoying bell. All right, so here we have a 30, 60, 90 triangle. Okay, now what you want to do is you want to make a chart so you can see the corresponding sides. So x is across from 30 degrees. The side across from 60 is x squared to 3, and the side across from 90 is 2x. Okay. Now for a 45, 45, 90 triangle, here you notice that you have 45 and 45. Well, x is across from both 45s, and then x squared to 2 is across from 90. Okay. So we're going to use these notes to find the missing parts of the triangles. All right, if you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, so it says find the value of sine, cosine, and tangent function for theta. All right. Wow, that's another very long bell. All right, now before we can complete sine, cosine, tangent, we need the missing side. Well, that's your hypotenuse. Now, we know from Pythagorean theorem that we can find the hypotenuse using a squared plus b squared equals c squared. Okay, so we know that 15 squared plus 36 squared equals h squared. Okay, well, to solve for h, we take the square root of both sides. So h equals the square root of 15 squared plus 36 squared, which equals 39. All right, so now we have h, 39. Now, you can write this down, SOHCAHTOA. That's used to remember SOHCAHTOA. So sine is opposite divided by hypotenuse. Well, now keep in mind, here's this. The opposite of theta is 15 divided by hypotenuse, which is 39. Now, that reduces to be 5 divided by 13. All right, now cosine. Cosine is adjacent divided by hypotenuse, which is 36 divided by 39, which reduces to be 12/13. Now tangent is opposite over adjacent, which is 15 divided by 36, which reduces to be 5/12. All right, so if you would finish up example 1. All right, so now let's take a look at example 2. Now, once again, we can't complete these until we have all the sides. So in this case, we need A. And the reason why I label that A is because we know this is A, B, C from Pythagorean theorem. So to find A, we know that A squared plus 16 squared equals 34 squared. So to solve for A, we're going to subtract 16 squared from both sides and take the square root. So A equals the square root of 34 squared minus 16 squared, which equals 30. All right, so now we have A is 30. So now we can use sine is opposite over hypotenuse, which is 16 divided by 34, which reduces to be 8 divided by 17. Okay, cosine is adjacent over hypotenuse, which is 30 divided by 34, which reduces to be 15 divided by 17. All right, tangent is opposite over adjacent, which is 16 divided by 30, which reduces to be 8/15. All right, so go ahead and finish up example 1 and example 2. All right, so now let's look at example 3. All right, so now here it says use trigonometric functions to find the missing values. And let me change that to say special right triangles. Okay. So we need to write we know this is 30, so this has to be 60. Because 30 plus 60 plus 90 is 180. So what we need to do is make a 30, 60, 90 chart. And actually, let's come up here. All right, now we know from our notes that 30 is x, 60 is x squared to 3, and 90 is 2x. Okay, so it looks like we have 90, so 90 is 74. Okay, so we know 2x is equal to 74. So we divide 2 by both sides, so x equals 37. So that means x is 37, because that's across from 30. And then across from 60 is y, which is 37 square roots of 3. So now let's take a look at example 4. Now we see here, again, it's a 30, 60, 90 triangle, because if that's 60, that has to be 30, and that's 90. So we need to make our 30, 60, 90 chart. So 30, 60, 90, which again we know is x square roots of 3 and 2x. All right, so let's see what we have. All right, so we know that 10 is across from 60, so this is 10. So now we need to solve for x. So we know that x square root of 3 equals 10. So to solve for x, we're going to divide both sides by square root of 3. So x equals 10 divided by square root of 3. Now you can't leave the square root of 3 in the denominator. So we need to multiply 10 square root of 3 times square root of 3 over square root of 3. Now, that leaves you 10 square root of 3 divided by 3. So x is 10 square roots of 3 divided by 3. And so that's across from 30. So that's 10 square roots of 3 divided by 3. Okay? Now, 90 is across from y, and if this is 10 square root of 3, then we multiply that by 2 for here, so that's 20 square root of 3 divided by 3. So your y value is 20 square root of 3 divided by 3. All right, so now let's take a look at example 5. All right, so we know here this is 45, so that's 45, this is 45. So again, we need to make our chart. So 45, 45, 90. And we know from our notes that that's x squared is to 2. And so let's see what we have. All right, so it looks like across from 90 is 7 square roots of 2. Okay, well that makes things easier because that means x is 7. So x and y are both 7. All right, so let's take a look at example 6. So again, we need our 45, 45, 90 table, because if that's 45, this is 45. And so then that's x squared roots of 2. So let's see what we have. So here, across from 45 is 3 squared roots of 2, so that's your x. So that's 3 squared roots of 2. And if that's 3 squared roots of 2, this is 3 squared roots of 2. Now, here we plug 3 squared roots of 2 in for x. So that's 3 square roots of 2 times the square root of 2. Well, the square root of 2 times square root of 2 is 2. 2 times 3 is 6. So 90 is 6. So across from 45 is 3 square roots of 2. And across from 90, which is y, is 6. All right, so now let's look at examples 7, 8, and 9. All right, it says find the 6 trigonometric functions for theta. Now, before we do that, we need to find the hypotenuse. Okay? And we know from Pythagorean theorems that we can do h squared equals 24 squared plus 70 squared. Well, to solve for h, we take the square root of both sides, so h equals the square root of 24 squared plus 70 squared. So h equals 74. All right, so now we have h, which is 74. We can do sine is opposite over hypotenuse. So opposite is 24 divided by 74, which reduces to be 12 divided by 37. Now cosine is adjacent over hypotenuse, which is 70 divided by 74, which reduces to be 35 divided by 37. All right, and then tangent is opposite over adjacent. So opposite is 24, adjacent is 70, so that reduces to be 12 divided by 35. All right, so now let's look at cosine theta. Cosine theta is hypotenuse over opposite. Well, that's easy. That's just 37 divided by 12. Secant is hypotenuse divided by adjacent, which is, again, easy. That's 37 divided by 35. And cotangent is adjacent divided by opposite, which is 35 divided by 12. All right, let's take a look at example 8. So again, before we can do the trig functions, we need to find the missing side. Let's call A. Okay, so we can use Pythagorean theorem. So A squared plus 9 squared equals 12 squared. Okay, so to solve for A, we're going to subtract 9 squared from both sides and take the square root. So A equals the square root of 12 squared minus 9 squared. So A equals the square root of 63. All right, so sine is opposite over hypotenuse, which is opposite. So let's write that there, 63. So opposite is the square root of 63 divided by the hypotenuse, which is 12. All right, cosine is adjacent over hypotenuse, which is adjacent to that is 9 divided by 12. Okay, and then tangent is opposite over adjacent. So opposite is the square root of 63 divided by the adjacent, which is 9. Now, these are just these flipped. So cosecant is hypotenuse divided by opposite. So that's 12 equals 12 divided by the square root of 63. Now, you can't leave a radical in the denominator, so we need to do this. So cosecant of theta equals 12 divided by square root of 63. So what we have to do is multiply the numerator and denominator by the square root of 63. So then you get 12 square root of 63 divided by 63. Okay, so now secant of theta is hypotenuse divided by adjacent, which is 12 divided by 9. Which I could actually have reduced that. 9/12 reduced to be 3/4. So this would be 4/3. All right, cotangent is adjacent or hypotenuse, so the adjacent is 9. I'm sorry, over opposite, and the opposite is square root of 63. So we need to simplify that. So the cotangent of theta equals 9 square roots of 3. So we have to multiply square roots of 3 by the numerator and denominator. So then you get 9 square roots of 63 divided by 63. Which that reduces to be square roots of 63 divided by 7. And going back to that, this actually reduces as well, so that this is actually 4 divided by 21. So this reduces to be 4 divided by 21. All right, so let's look at example 9. All right, so again, we need to find the missing piece, so let's call that B. So we know that 21 squared plus B squared equals 35 squared. So we're going to subtract 21 squared and take the square root. So B equals the square root of 35 squared minus 21 squared. So B equals the square root of 784, which we can write that as the square root of 4 times 49. Well, the square root of 4 is 2. The square root of 49 is 7. So 2 times 7 equals 14. All right. So sine of theta is opposite divided by hypotenuse, which opposite is 21, divided by the hypotenuse, which is 35. And then cosine of theta is adjacent divided by hypotenuse, which is 14 divided by 35. And then tangent is opposite over adjacent. So the opposite is 21, adjacent is 14. All right, and then cosecant, secant, and cotangent are very simple. They just flip. So hypotenuse over opposite, which is 35 divided by 21. Secant of theta is hypotenuse divided by adjacent, which is 35 divided by 14. And cotangent adjacent divided by opposite, which is 14 divided by 21. All right, we're going to omit example 10 because we're going to actually go over that concept in assignments that are coming up. So with that, go ahead and finish up your examples. Now, at this point, if you understood the examples, then you're ready to work on the assignment on your own. If you had trouble with the examples, just know that we're going to start working on the assignment in class, and you can work in that group with me. Okay, so with that, have a wonderful Wildcat day.